All right. So some of the natural service functions of cyclones. So within the winds of the cyclones, they may carry plants, animals, microorganisms within the currents themselves, and they may carry them to locations across the ocean, through which there would be no other mechanism for these plants and animals and microorganisms to get to. So that would help basically populate volcanic islands, for example, or even just carry out the genetic material of certain species across the oceans. So that is one of the natural service functions of them. Another one is that waves could stir up the deeper nutrient-rich waters, resulting in plankton blooms, for example. So if the waves are crashing and there are greater waves crashing, they're able to stir up the material underneath, all that sediment, and within that sediment that was initially out of reach for all the organisms, there may be a bunch of nutrients that they could now use. So it might result in, blooming of some of the species, such as plankton. And as you may know, whenever plankton blooms, a bunch of other species within the ecosystem also flourish. Not flourish, just bloom. Sorry. It's a Spanish term for that kind of growth. And so sometimes I decide to translate it, but not really, just making up my own words. Okay. It may also, for example, rejuvenate ecosystems such as forests, reefs, etc. So it may basically, as the next little point says, it may topple dead and diseased trees from forests, and it may also take down all the coral parts that are dead and no longer working, or it might clean out those that are living and well, from, for example, any human remains that have been stuck to them, for example, or any sediment that was deposited on them and is no longer letting them grow at the speed that they used to, for example. So those are two ways in which we can rejuvenate different ecosystems. Another way is that it can be the primary source of precipitation in many areas of the U.S. And of Canada, amongst other places in the world, for example. So just to give you a location in the western U.S., and let me fix that real fast. Again, in the western U.S., extratropical cyclones that are the main precipitation source during the winter season. So this happens a lot in the Great Plains, for example. These are the only ways in which they get precipitation during this winter season. Also, snowstorms that we know are effects from extratropical cyclones can turn into snowmelt once the spring and the summer seasons come. And that snowmelt may be one of the only sources of precipitation as well to many regions. So obviously it's very highly needed. So many times this tropical and extratropical cyclones may be the only way in which certain areas in the U.S. particularly receive water. Particularly extratropical cyclones are more important in this last factor than tropical ones, and they are obviously more relevant in the western U.S. and in the Great Plains than in the eastern coast and southeastern part of the U.S. All right, so what is human interaction with cyclones like? So we know that the human interaction overall with cyclones has increased over the past 4 decades a lot, and this is because of the population growth, at least in the U.S., and this population growth in the U.S. has been happening for the most part in coastal areas. So actually about 53% of people in the U.S. live in coastal counties, which is a lot if you think about it. Counties that have, or areas that have especially grown in those past 4 decades have been the Galveston area in Texas, also the Miami-Fort Lauderdale area, and the Tampa-St. Petersburg area in Florida, and as you know, the Hamptons in Long Island. Also, most of South Carolina coast has been growing very dramatically, and this is many a times from people who are retired and are able to live in those warmer coastal areas. Actually, my sister, she is an economist. She's just finishing up her PhD right now, and she's going to work for the World Resources Institute in the New Climate Economy group. And her research for her PhD was about different policies that were, or hypothetical different policies that would be made by government officials, and how they would reduce the amount of flooding that would be experienced in the South Carolina coast. So depending on policies such as not letting people construct, or just making insurance more expensive, or increasing the tax in this or that construction laws, for example. So it was a pretty cool overall research project that, had to do with the growing population that is not being controlled very well in these areas, and what that has to do, and how that impact is going to affect us both monetarily and in terms of life. So many times, this can be very dangerous, this population growth in coastal areas. There may be simply poor construction being done, so this is obviously hazardous to humans. So if there's poor construction in coastal areas and they are hit by hurricanes, then the repairs are obviously very costly. Many times this poor construction leaves parts of the buildings or the infrastructure that is constructed to fall off the main infrastructure, and they may become projectiles themselves during the storm. Meaning, if a roof is not very well made, the tiles from that roof may actually become projectiles within the storm once they get incorporated within that hurricane. So that's obviously very damaging. Also, construction wow, give me 1 second. Okay, so it was not bare, it was near. So the construction near ocean fronts causes erosion, as we know, right? For any materials to be, laid there and made infrastructure, you have to basically make the ground flat, make sure that you meet regulations, put down the foundation, so on and so forth. So overall, what you're doing is causing erosion. And this construction making causes the erosion, which in terms allows for easier erosion by the cyclones as they come in, because the ground has already been debilitated by the construction. Also, the human overall contribution to the temperature rise, as we're seeing it globally, may warm the oceans, and hence more tropical cyclones will occur. So that's the overall effect that I was talking about on this slide. So that directly related link between cyclones and climate change. So those are some of the human interactions that we have had with cyclones and will continue to have for however long we're in the planet. So we'll go through some of the effects to minimize, some of the things that we can do to minimize the effects of cyclones in the few coming slides. So some of the things that we can do to minimize the effect of cyclones are to, basically the first way to do it is to forecast accurately when a hurricane is going to happen, or an extratropical cyclone. That is going to help us reduce the amount of damage that we see in terms of money that it costs us to fix the damage, and also to avoid any life from this cyclones. Another thing that we can do is to enforce building codes and evacuation procedures. Okay, so in terms of the forecast and warnings that we can do, the U.S. National Hurricane Center, which is in Miami, Florida, and then the Canadian Hurricane Center, which is in Dartmouth, Nova Scotia, are two centers that monitor hurricane activity pretty well. The one in Miami, Florida, kind of looks over the whole Gulf Coast, eastern coast of the U.S., and the one in Canada monitors mostly the Atlantic coast of the Canadian country, which is pretty cool. So in the U.S., a hurricane watch is issued when a hurricane is likely to strike within 36 hours. However, obviously, as we know, we usually get news updates on how the hurricane is developing and when it might possibly strike much earlier than 36 hours before. It's probably like 5 to 7 days before that we start getting news about it. But again, a watch itself is only issued 36 hours before it strikes. And then a warning is given when it is 24 hours or less from its striking point. In Canada, it varies, but it's a very close kind of procedure that they follow. So in terms of the hurricane forecasting tools that we have a few. So weather satellite is probably the most powerful tool for hurricane detection. So the satellites can basically detect a storm that is forming over the ocean way far from any land features that we might use, any tools that we could have. So they tend to give us early signs of development, which is very key. It lets us keep track of how things are developing. We also have aircrafts that help us as tools. So these aircrafts are the hurricane hunters, and they are flown directly into the hurricanes to collect data. This data is mostly about the intensity of the hurricane itself, so that would let us put the hurricane into a specific category. Let us know how strong the winds are and how much water we're going to be able to see when it strikes. So the way they do this is that the aircraft literally goes into the hurricane, and it will drop basically a weather station sort of deal in the eye of the hurricane, and then it will continue to go through the other side of the eye wall and continue on. So the hurricane hunters, as they're called, it's an aircraft by the U.S. Air Force, and they perform most of the reconnaissance of these hurricanes. So currently only the U.S. government uses such flights. No other government does this. And it's only done in the Gulf of Mexico, the Atlantic Ocean, the Caribbean Ocean, and a few areas around Hawaii. But it's not done, elsewhere in the Pacific, for example. So another tool that we use is the Doppler radar systems, which I referred to in the last chapter. So again, I'm not going to go through it in detail, so definitely check the last chapter if you're curious about this one. So basically that lets us have an idea of how the hurricane is looking 320 kilometers from the mainland and also from some island. So it doesn't give us a whole lot of data if it's very far away, but it gives us a fair amount of data once it's 320 kilometers close to the mainland. But again, if the hurricane is moving 25 kilometers per hour, that only gives us like 12 hours head notice or so. So it is good, but it's not, a long-term kind of forecasting tool. Okay. We also have weather buoys that are floating along the Atlantic and Gulf Coast. And this, we also get some information about at least how much rainfall we're seeing in those specific locations. And perhaps what is the wind speed at the surface of the ocean. So that might vary, but we can see some things based on that. And lastly, we have computer models, which are very helpful, but are not perfect, as you might know if you have worked with any models that are made. So they're definitely used and give very good data the closer to the event that they are. But they lack a lot of knowledge about the intensity. So that is why aircrafts are still very widely used. Once you get information back from the aircraft and you input it into the computer model is fantastic at giving you the information. And again, it's better at doing so the closer to the event than that the computer model is run. So if the event is, potentially happening in the next 24 hours, the computer model is great at telling you what the storm surge is really going to be, what the winds you're going to experience are, and which location specifically, how much rainfall you're going to see, for example. That's a very good tool, but it needs a fair amount of data prior to the running of it.